So once you plug in, what am I going to get?
Zero.
First term is going to be 0. Good. Second term is going to be what? -1. Rad 2. And the fifth? Rad 3. Then 2. Now, later on, you want to think about in reverse now. If I give you this, right? Can you generate this?
I'm like, no, that's so fun. That is so fun.
So later on, it's going to be the other way. So right now, just an introductory to show you how is one direction work. In math, it's always both directions, and in this case, the second direction is going to be more easier or more harder. So that's what you want to think about. So, is any questions here before we move on? Because this is the first time I teach this, so it's going to be kind of challenging for me. And but yeah. What do you think this pattern of the next one is? So can you come up with a pattern that represents this?
Are these simplified answers or no?
It's gonna be in terms of n. So what you're gonna do is you're gonna come up with these things here, and how do you come up with that sequence? By looking at this pattern now. And you're gonna start with, of course, you're gonna start with first term in this case.
It's n plus 1 over rad.
Don't shout it because other people don't think when you shout it.
It's starting from 1.
You start from 1. So is everybody okay? So you look at this one, right? You see the first term is 2. And you see, for me, I will focus on two separate things. I will focus on numerator and denominator. Okay, so in this case, the numerator is 2, 3, 4, 5. It has a very easy pattern. It's like just like an n, but except your first term is not 1. Your first term is actually 2. So the only way that's going to make it work is n plus 1 for the numerator. Does that make sense?
Yeah.
And the bottom is 2 over 1. Now, if you look at it, pay attention, the pattern of the bottom is going to be, yes. Hello, Barry? Yeah, like my charger is actually being weird. Let me see. Okay, so and now we're just gonna get this one, n plus 1 over square root n, and that's what we come up with. So we look at separate things. So one technique you can look at is look at the pattern of the numerator and denominator and decide what it's gonna be. So if you see that, that's gonna be 2, 3 over 2, and stuff like that. So other pattern that you can try. So we're gonna pick out, see if any other pattern we can see. Give me a second. Let me see what's the next pattern I want to give it to you. Okay, so next pattern is going to look like this one. Connor, don't shout your answer. You can whisper to Bobby.
What is that on the bottom?
-1, 1 over 2, -1 over 6, 1 over 24.
This one is different. This one's not like the one that you've seen before. And you might need learn a new notation. Some of you guys remember this notation?
Oh, I don't like this already.
What's the second to last?
1 over 24 and negative 1 over 120.
I don't like this.
So should I introduce your new notation?
Oh, I think I know what this is.
I start being zero.
Right?
You might need me to teach you a new
I
notation.
think I know what it is. I think
What does the notation look like?
A n minus 1. No?
Have you guys looked at that there's a math symbol look like exclamation mark?
Oh!
No, we're good. Don't tell us anything. It's okay.
No,
No, we
you
didn't.
explain that.
I should explain that. Okay, let me explain that. If you have, let's say, if I have, let's say, 5 factorial, that's equal to 5 times 4 times 3 times 2 times 1. Okay, 4 factorial is going to be equal to 4 times 3 times 2 times 1. 3 factorial is going to be 3 times 2 times 1. 2 factorial is going to be 2 times 1. 1 factorial is going to be what? 1. Now, very, very important. There's one more. There was a 0 factorial. 0 factorial is 1. Okay.
No, that makes no sense.
That's wrong.
How is 1? You didn't know? You didn't see the pattern? Look at the pattern again and tell me why it's 1.
Oh, because 1 is always there. It's just 1, because 1 factorial is really just 1 times 1. And then it's 2 factorial, 2 times 1 times 1. 3 factorial, 3 times 2 times 1.
Yeah, so, and also you can look at it this way, right? If I'm going down here, what do I do? Divided by 5, right? And when I go down here, I divide it by 4. Does that make sense? And divided by 3. And divided by 2. And then divided by 1. So 1 divided by 1, still 1. Don't ask me about negative sign because I don't know.
Hey, what about negative sign?
No. I might be able to answer you next year.
Is there such thing as a factorial tangent or not?
Well, don't think about
Factorials, don't even talk about trig factorials. No one even think about that.
Okay, with that knowing the new notation, can you figure out, don't shout your answer again. Can you figure out what is the new situation and what is the sequence will look like? And you might need the help of factorials. You got it, Margot? Cool. Connor got it too?
Yeah,
This
I
is
like
way,
this.
way better than
I like this part.
this is like patterns.
Yeah, it's a recognized pattern. It's a much more sense for a lot of intuitive kids that who just kind of make sense and look at a pattern and make sense.
You should have put trig into it.
He is gonna put trig into this. He's not gonna hit you.
No, they can be different. They can be a little bit harder. You want me to give you a harder one for you guys
Well,
to
no,
see?
trig wouldn't even be that bad because you'd have to be able to recognize the pattern still. As long as you know the derivatives, it wouldn't.
Okay, so Matthias, what's your pattern on this particular question?
Negative 1 to the n power over n to the factorial or exclamation over.
Over n factorial. Okay. So you'll get negative 1 over n because your first number to be negative, second number to be positive. So you want to do negative 1 to the n. Now, if you want the first number to be negative, what would you do? Oh, you want the first number to be positive, what would you do? N plus 1. So negative to n plus 1. So now you learn a new technique is how do you adjust that situation and how do you make that sense of works. So is this okay before we go on further? Okay, let me give you another one. See if you guys can figure out this one.
We're gonna have homework on this tonight.
Probably. Okay.
What the heck?
that
What
was
got into you?
that was funny. Okay, so I'm gonna think of patterns if you guys can figure out. So I'm gonna give you a little bit more interesting pattern. The first one's a -1. Yeah, I'm making this up and to try to challenge you a little bit more.
Trick into it too.
No, I'm not gonna put trick into it.
I feel like that might throw it.
You don't think Trick's that funny?
The first one, second one's 2, 7. This is an interesting one.
Whoa.
Wait.
Whoa.
That's it. You want me to give you one more?
Yeah,
No.
yes, please.
All right.
Wait.
Oh.
What? That made it even more confusing.
Logic than
Wait.
than math.
Oh, I know the pattern. Alright.
Oh, I know the pattern.
I think so. It's something you have. It's not super weird compared to this.
It is weird. It's not numerator and denominator.
It's not at all.
This is just some harder one. I give it to like Algebra 2 kids, see if they can figure out. But usually they cannot see it right away. It's like a little bit harder.
I just need to figure out the right number.
Is that say 123?
No, it's a -1, 2, 7, 14, and 23. Did you? Okay. Did you verify all the numbers? See if it's true. Ooh, okay. Puppy is sad.
Oh, wait, that's not it. Never mind. Oh, I got it now. Now I got
Are you sure? Show
it.
me.
Maybe.
Nisha trying to race with Jonathan. Yep. Good job.
Oh, I'm literally, dude, I got it
Which
wrong.
one?
Wrong.
Hold on a second. Yours is actually so that doesn't make sense.
The last term. The last term.
That doesn't make sense.
Yes, it does. It's the last term.
That
So,
doesn't make
like-
sense.
For
This is-
for 2,
Yeah.
it would be -1. For 7, it'd be 2. For 14, it'd be 7. For 23, it'd be 14. That's what.
Oh, you're thinking about recursive.
Yeah.
No, we're not doing recursive.
Dang it.
But it
We
was-
haven't talked about recursive yet.
When you said that it's going to by odd numbers.
Yeah, it's going
Okay, so one recursive formula.
Okay, I don't know how to. I just don't know how to
got there.
Like, I know-
There's no way to know this. Just pure logic. Pure logic.
Oh, so there is no actual notation for it. You just have to write down the pattern. Yeah.
No.
Oh, yeah.
You're thinking about recursive.
Well, yeah, because that's what it is.
It's much easier than that.
It's all okay. Oh,
No,
so
look,
it's
the
not,
difference
we don't have to write an actual equation for this one.
It's going up by.
Yeah, so you're
I
thinking about
I
you
still
think
know how to
about
write that.
you
down.
think about recursive.
So this is
You
Okay,
you
but-
really need a prior term to figure out what is the next term.
But that's the exactly. But that's the pattern. I still
Yeah, but how do you figure out a equation that fits this
Isn't the
pattern?
equation for this?
Yes,
You know, I know the
there was two people figure out. There was Liam and Nisha figure out.
All right. Good.
How do you write this equation?
Yeah,
I know what it is. I just don't know the equation.
Yeah.
So yeah, so I like I said, this is a very challenging algebra 2 question. So it will stump most of the calculus kids. It's because it's people don't recognize certain things. You gotta look at different possibility here. So I'm just training you to look at different things, and then you guys are actually lead to the next question, which is called recursive formulas. So we're gonna talk about that recursive. I'm waiting for you to figure out. There's two people can figure out. So can you? Nobody?
Wait a minute. No. I got it.
I don't understand how you, I know the pattern exactly,
I know you know the pattern.
but this. Yeah, no, it's the weird. It's just the weird algebra too. Is it really? I feel like it's something that we're thinking way too much about. It's super simple.
Yeah, it's super simple. It's super simple.
Wait, hold on. Wait. My mind's got something. Hold on. Wait.
Nisha is like, Jesus, all you.
This makes complete sense right here. Now,
I got it. Yeah, here we go.
Gabby, did you get it?
I got it by proxy.
I get it.
Proxy means what?
Oh,
Like, I was like, is it?
no, I didn't.
Okay, no, I did
This
this.
isn't it.
I did.
This isn't it. Wait, what?
Yeah, I have the equation.
Oh my God, this is
Is it,
pissing me off.
he has the equation, or does he have the pattern?
He has the equation.
Yeah.
What the heck? Dorks.
Margot, did you have it?
That's right.
You were thinking about recursive. Most of you guys think about recursive. Yep, that's it.
Oh,
Oh, wait. Wrong sign.
It's just this. Right?
Yeah.
So it is super simple. It's really simple.
There you go. Yeah. So here's the answer. N squared minus 2. So sometimes you had to look at things a little bit different. So you cannot just always look at things in perspective with this. You gotta think about all this possibility inside your head, and this is a good challenge to teach you how to do things. Now, luckily, like Connor and Jonathan, you guys actually come up with another thing called recursive. Recursive is
Which is technically correct, though.
It is correct.
well, recursive. We haven't taught that yet, but recursive is gonna be like something like this. So suppose A1 is equal to 2. And A2 is equal to 4. And we say there is a equation here. This is going to be a to the n plus 1 over 2 to the n minus a to the n minus 1.
Wait, what did that say on the right? That equals to what?
This is the formula I'm giving to you. Just like before, I give you a formula first.
Well, what, I can't read what that says on the right. What does that say on the right? Like an plus 1 equals 2 what?
Okay, a to the n plus 1 equal to 2 to the an minus an minus 1.
Okay.
So then I want you to try to figure out first couple terms. We already know the first term. We already know the second term. Can you try to figure out the third term? Just look at things. It's given to you. The formula is already given to you. So you just have to figure out what the third term is.
Just the third term or more?
Just the third term.
Well, I'm a little confused here between the different A and N.
Just the third term.
What is A?
Just a third term. I just want a third term. It's, you can tell me it's even or odd. I'll tell you if it's right.
Even.
Good. It's a
Multiplication of two prime numbers.
multiplication 2 prime number. What? Is it? It's not prime number. No.
No, it's not a prime number, but it's okay. No.
Okay, that's okay. But I think you got it.
I'm just confused on the whole A, the difference between A and N thing.
So that the notation you guys start to figure out. We have a to the 1, we have a to the 2. What do we missing? A to the 3, right? So we want to figure out what the A3 is, right? This is the A3.
But if you plug in 3 for N, then it's A to the 4. That's my confusion.
No.
Plug in 2.
Plug in 2 to get A flat.
Because that
So wouldn't
equals
that be
A3.
Oh, okay.
So it'll be
I still
a to the 2 plus 1, right? Does that make sense? Is equal to 2 times a to the what?
2.
2 minus what?
A2 minus 1.
A to the minus 1. So that's going to be 2 times what? 2 times 4 is 8. 8 minus what? 2. So that's going to be your 6.
You were saying
She was right.
Wait.
It's two
She's
prime
right.
numbers. 2 times 3. Yeah.
2 times 3. Oh, okay. Yeah, 2 times 3. I was thinking about it. So that's 6. So yes. What about the fourth term?
Oh, easy. Now yeah, we got.
So this is called recursive. This is another way to show you a pattern. So this is called recursive formula. So it's based on the 2 separate terms. Usually you don't use this, but just
Equal 8. Well, this recursive formula.
12, because you keep doubling it.
There's no reason for this recursive.
No, because then you also have to subtract a higher number.
it's based on the 2 prior term. If you think about it, your next term is based on 2 prior term. So you can come up with an equation that based on this too. So
Don't be mean to it.
So this is a recursive sequence. A recursive sequence cannot find a certain terms without a prior term. You cannot figure out the next term until you figure out a prior term. So usually they give you a recursive formula. So in this case, a to the 3 is equal to 2a to the 2 minus a to the 1 equal to 6. What will be the next term? 8. So same thing. If you go to the next thing, that's going to be the same thing. Is it confusing or no? No, you just have to figure out what happened, what is a recursive formula is going to be. So a lot of time that you guys have to think of it in the term of this way. It's just pretty much a pattern recognition. So yeah. So we're going to talk about a couple more things. We're going to talk about limits. So limit is a sequence of a to n as limits. If limit n approaches to infinity of a to the n, if limit exists, then the sequence is convergent. If not, the sequence is divergent.
Wait, what's going to infinity? Is it a to the n?
N to the infinity. So there are 2 choices. The a to the n is like 2, 4, 6, 8, 10. It just keep on going up. It's going to go to infinite. But what if it's a 1, 1/2, 1/4, 1/8? What does that goes to?
No,
No,
it goes,
it's negative.
it goes to one.
It goes.
No, you're talking about series. A series will be adding each term, but eventually that term is gonna go into you're gonna go to a certain number, right? You're gonna go to, if you're getting smaller and smaller each time, it's gonna go to 0.
The series would be one.
Series will be 1. So, well, depending on what you start. If you start at 1, then it's gonna be 2. So it's like 1 pizza, add a half a pizza, add a quarter pizza, add a 1/8 pizza, add a 1/16 a pizza. You keep on adding. That's what's called series. Series is adding. A sequence is just a term. We're not talking about series whatsoever. Okay, let's write down some properties. So the property is very similar. If you have constant in the sequence, you can always take this constant outside. It's just kind of like derivative, kind of like integration. Constant is like nobody's business. Just like, hey, I'm out, right? That's a constant. Because that usually make a calculation so much simpler and so much easier. If you have two different type of sequence, basically just one sequence added to another. Which one? This is C. So this is that's probably the most important one. Other ones, it's very intuitive, but everything is kind of like very, very similar to derivative, and it's like integration. Integration, you cannot multiply to integration, but in this case, just gonna be
Is
like
that
this.
just saying that you can take out the constant?
Yes. Just like a derivative. You take a derivative 2x. You actually take a derivative of x. You don't take a derivative of 2. Right? You just take a 2 out and take a derivative of x, which is 1. So 2 times 1 is equal to 2. So that's basically the same rule as what you did before. It's no different. You hate what? Limits?
Like writing it out.
LIM?
Too much, yeah.
Too much writing?
So this is like all the same properties for like integrals.
Well, you cannot do integral of this though. Like say, if you integral of two
I'm
functions, they
saying-
cannot multiply two
No, no,
functions.
I'm saying the rules apply.
The rule pretty much apply. This is the same rule throughout pretty much different things, like in the past.
I say you can't you can't split apart integrals that are multiplied.
Yes, you cannot do that with the integral. So that's why I say not, except that rule number 3 is going to be, rule number 4 is even as well, because division doesn't work with
Right.
integral either. And number 5, yeah.
He doesn't stand for anything specific, right?
How much? Huh?
He doesn't stand for anything specific, right?
P just could be P just some type of power. P stand for power. Get it? Okay, so now we're gonna talk about some type of series. Are they convergent or divergent? If I just have -1 to the n, is that convergent or divergent? It's -1 to the n power.
It's
It's
convergent.
convergent, you get a
No, but you're not for sure what that number is.
But divergent.
It's a divergent because you fluctuate. It's like an on and off switch, right? It's on or off, on or off. But if I give you any time that comes in, that do you know, if I told you, like, if when you walk in the room, when you come inside, right? and you blindfolded. I mean, or like something you cannot see, a total you cannot see. You don't know it's on or off, so it's not for sure certain. It's not certain to a conversion is going to go toward a number for sure. For if it's a -1 to the n, in this case, this is a diversion. Because it's not going to for sure to a same number. You're not for sure entirely sure that they go into a certain things. Because if I say stop right now, it could be 1 or it could be -1.
Can you show us what that looks like on Desmos?
This one?
Just -1 to the x.
I think it's just bunch dots between -1 and a +1.
Wouldn't it not be a bunch of dots? Like, wouldn't it be like a curve?
Where would it be curved
Well, I
though?
don't know, what's -1 to the 1?
Well,
Yeah, that's Kirby. I was teaching my son how to draw a Kirby. -1 to the x, right? And the thing is, they cannot be fractions. So you have to set, because when you graph as a function, you cannot do in term of -1 to the 1.2 power. It's really, really hard to figure out. But yeah, they don't even show. It only show the first dot, but doesn't even show the second dot. So, no. The second one you should already know. Remember we're doing horizontal asymptote? Remember that case? Remember we're doing horizontal asymptote. We start with 2n over n plus 1. And you learned that in pre-calc as well. In pre-calc, just take the highest degree. If they have same degree, and take the coefficients. That's the exact same way. But you cannot do that in Calc BC. In Calc BC, you really have to show this. Remember, you divided by highest power on denominator. Do you remember that? You divide the highest degree of denominator. This one for sure you're going to use all the time. This is like super important. Right? You take the highest degree on denominator, which is n to the first power. You divide everything to the n. Right? You divide this, the numerator by n. So you pretty much look at the same exact rate. So then you're going to get 2 over what?
1 plus 1.
1 plus 1 over n. But if this part approaches infinity, what will happen?
0.
0. So that's why your answer is 2.
So that.
Well, do you need to do that, or couldn't you have just seen that it was 2?
No, you have to show me the work. You have to show me the word that you divided by n top and bottom. We're going through the whole section of this, right? We're going through like the case like, let's just say 2x over square root of 3x squared minus 1. We did that before. What is the highest degree on denominator? Well, okay, I want you guys to figure out this. What is this? Limit x approaching infinity. Also known as what? If you're looking for infinity, you're looking for what? Horizontal asymptote, right? So horizontal asymptote. So how would I do this question if I just say limit x approaching infinity? Divided by highest degree of denominator. Sorry, I forgot to write down. Denominator. Highest degree of denominator, and you approach infinity and see what a number goes to, because a lot of terms usually go to zeros. Do you guys remember how to do this? We did this in Calc 1.
Is it Logan told us?
No, not LP. We just show you how to do it.
Oh, they're to the same power theory. It's 2 over 3.
No.
What?
Well, yeah, the answer is 2 over 3. But how? Look at the highest degree on denominator is what?
3.
No. It's x squared square root. So it's actually x squared inside radical. So you divide it by top and bottom by x. But if you divide it inside the radical, that becomes square root x squared. Does that make sense? And then that top part is going to become 2. The bottom part is going to be 3x squared over x squared, which is that become 1, right? Minus 1 over square root x squared. And except this case, when the limit x approaches infinity, what will happen?
The 1 over square root of 2.
So 2 over what?
Square root of 3.
2 over square root 3. Do you guys remember this? We did this in Calc 1. It's on the second test. When did you pass a test?
I passed 2 tests this year. I'm pretty sure. Should at least do.
After my help, maybe. So in this case, that you did the same thing. So you could have those alternative situation, right? And then you divide by top by this. And then, so this part, it doesn't matter anymore. If you pay attention, this part does not matter anymore. Because it doesn't matter if it's a -1. On the top, it's going to be -1 or 1. But the bottom is going to approach infinity. So does that matter if you have 1 over infinity or -1 over infinity? That's still going to go to 0. And this part is going to go to 0 as well. And this part is going to go 1. So this one's convergent. We didn't finish to talk about the next 2, but we finished to talk to case 3. And I'm going to say, yes, this is my learning process. So hopefully you guys gonna go along with me. But this is the first time I teach this. But I'm not doing a crappy job right now. As of now. Maybe later, but as of now, I'm not doing a crappy job. At least I don't think. It's okay? Yes. Wait, you're talking about Parati?
No, I'm talking about like now.
Okay,
Like-
it's okay.
Like, no, I'm talking about like
This stuff is easy for you?
no, but yeah, I'm talking about project. But I'm talking about how was that in terms of project.
Oh, okay.
Can I?
Like, was that good, or do you want us to have more?
I need to go talk to him. I need to see how the
No,
procedure
no,
goes.
I'm asking you if you need any more from me.
Yeah, today is much better.
Can I do the test during lunch? I don't have a way to go home after school later. My 5th period ceramics, so I don't have to.
Oh, okay. I just worry about a test too long for you. Yeah.
It's just ceramics, so it's not be important.
Okay, cool. Yeah, I'll see you this afternoon. Bye.
What?
Yeah, I can come by now.
Oh, okay. 那你就过来吧。
Okay.
Students, 1 minute remaining until class.
You said like you had like test graded, right? Last week or no?
Last week, you know. But it was bad though.
You just know that we all failed.
Pretty much, yeah. Like, you guys didn't really study. There was like 3 questions exactly from the notes, actually.
I'm
Yeah.
just gonna stay here because it's cold and wet out there. So